Welcome to this comprehensive video tutorial on Java debugging. If you've ever found yourself staring at your Java code, scratching your head, and wishing you had an easier way to identify bugs, you've come to the right place. Today, we will dive deep into various techniques and tools that will help you debug Java applications efficiently. Before we jump into debugging techniques, let's first understand what debugging is. Debugging is the process of identifying and removing errors or bugs in your code. Bugs can be syntax errors, logical errors, or runtime exceptions. Understanding the type of bug is essential for effective debugging. Now, let's write a simple Java program to demonstrate how we can introduce some bugs and then apply debugging techniques to fix them. We'll create a program that calculates the average of an array of integers. Let's start with our basic code for calculating the average. Now that we have our code, let's compile and run it to see if it works as expected. Let's check for any compilation errors first. You might notice that there is a potential issue in the loop condition. When we try to run our code, we'll find that it throws an array index out of bounds exception. That's because the loop condition is using less than or equal to sign instead of less than sign. This means it attempts to access an index that doesn't exist. To fix this issue, we simply need to modify our loop condition. Let's change it to use less than sign instead of less than or equal to sign. This will ensure we only iterate through valid indices of the array. Let's run the code again. We should now see the correct output. The average is 30.0. Great. But what if the program works fine and we still get unexpected results? This is where debugging comes into play. Next, let's introduce a logical bug. What if we want to calculate the average, but we accidentally forget to divide the sum by the number of elements? Let's run the code once more. You will notice that it simply returns the sum instead of the average. That's an instance of a logical error where the program syntax is correct, but the logic does not fulfill the intended purpose. To solve this, we need to ensure we include the division by the length of the number array when returning the average. Let's revise this now. After implementing the fix, let's run the program again. Now we receive the expected output. The average is 30.0. Awesome! We solved both an array index out of bounds exception and a logical error. But there's more we can do to debug effectively. Another powerful tool at our disposal is the Java debugger. Most IDEs, including popular ones like IntelliJ IDEA and Eclipse, come with built-in debuggers. Let's take a look at how we can set breakpoints in our Java code. A breakpoint is a line of code where the debugger will pause execution, enabling us to inspect the state of the program. In your IDE, you can usually set a breakpoint by clicking in the left margin next to the line numbers. Let's set a breakpoint at the line where the average is calculated, just before returning the value. Once the breakpoint is set, run the program in debug mode. The application will launch, but execution will pause as soon as it hits the breakpoint. At this point, you can inspect the values of variables, step through the code line by line, and determine how the program state changes. Let's step through together. You can inspect the sum variable to see how it accumulates values during each iteration. This real-time insight is invaluable for spotting logical flaws or unexpected behavior. In addition to breakpoints, we can also utilize watch points, which allow us to pause execution anytime a specific variable is accessed or modified. This is helpful when we want to watch the value changes in specific variables during the execution. Another debugging technique is using logging statements. By adding logging to your code, you can monitor its execution flow and the state of variables at any point. Logging frameworks such as Log4j or SLF4j can help manage log outputs effectively. Let's try adding a logging statement to track the sum as we accumulate it in our calculate average method. This allows us to monitor how the sum changes with each addition. Another important aspect of debugging is understanding exceptions. Whenever an error occurs, Java provides a stack trace that shows the exception type and the method call that led to it. Learning to read these stack traces can significantly speed up your debugging process. Let's induce an intentional exception in our program. For instance, we can modify the main method to try and calculate the average of a null array. When you run the program now, you'll see a null pointer exception alongside a stack trace in the console. The stack trace shows you exactly where the problem occurred. This is a tool that guides you back to the precise line or method where things went wrong. Another important aspect of debugging is writing unit tests. Unit tests can define specific behaviors that we expect from portions of our code. If our code deviates from these behaviors, the test will fail, helping us catch bugs early. With unit tests in place, any changes you make to your code can be quickly validated against these tests, ensuring that you haven't unintentionally introduced new bugs. In conclusion, we've covered various aspects of debugging in Java, including understanding and fixing syntax and logical errors, using IDE debuggers, employing logging, interpreting stack traces, and writing effective unit tests. Each tool and technique plays a vital role in the debugging process. As you grow in your Java programming journey, remember that debugging is an essential skill. Familiarize yourself with the tools and techniques available and practice using them as much as possible. Thank you for watching this tutorial on Java debugging. If you found this video helpful, please give it a thumbs up, subscribe for more content, and leave a comment below with any questions or topics you'd like us to cover in the future. Happy coding!